All right, I am seeing some more people tuning in. Looks like my stream. Okay, I think we're back. I'll give another minute or so to let people back on, and then we will wrap up with our review example. Okay, sorry about that. Vimeo and OBS just quit communicating. I don't know why. It said Vimeo's DNS settings were off. Something were just just messed up, and then we confidence intervals, and the do part is in the calculator, okay, and then we want to conclude. So, and that top sentence is sort of your can statement. That's really what you really. We back offline. Things look good on my end. Okay. Sure that you okay. We're going to continue on and see if we can get through this. So our example is from the 2017 AP Statistics, the free response, and it says the manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink from the bed of the cup with water. The manager selected a random sample. So the first thing, and I guess you need to make sure that you clarify what is that true what is that true proportion? What is it that you're trying to decide on? So the state, we're looking at the true proportion of customers with soft drinks. So I need to clarify what that is so that the reader knows what it is. The problem, it says a random sample of 80 customers. You want to be sure that you be sure that you get those points. You want to be sure that you get the random sample of 80 customers. So quote that, just quote the problem. I know we say not to plagiarize, but in this case, you definitely want to just quote the problem. Okay, make sure you can't just put random check. You have to actually state where in the problem does it specify random. Okay, independent, that's your second condition. It is reasonable to believe that there are 800 customers at the restaurant who get water cups. Okay, there was a sample of 80. It's reasonable to believe that there are 800. Okay, so I just multiplied that by 10. That's also known as the 10% condition. I like going the opposite way and multiplying the sample times 10 to be reasonable for our population. And then normal, you want to check the large 80, 23 over 80 was my do. In your calculator, you're going to do a 1 prop z interval. I will show you how to do that. Hopefully my 80, and then it's 95%, and I'm going to calculate. Okay, so that is how you get your answer for your confidence interval. Just put in your proportion. That's all you're doing, okay, and your confidence level. That affects your z-score. Okay, and that is what we have there. So that's how you get your answer. And then once you get your answer, then you conclude. Okay, so we are 95% confident that the true proportion, there's that allusion to the population proportion, of customers who use a water cup for soft drinks is between 0.1918 and 0.3995. Was that a different answer than what I had? I think I wrote the wrong answer. 8832. I don't know what I messed up on there. This is very, very close though. Okay. It's probably going to mess with my answer on the next part too. All right, so that's your answer there. All right, so then the next part of the answer, okay, the manager estimates that each customer who asks for a water cup but fills it with a soft drink costs the restaurant 25 cents. Suppose that in the month of June, 325 cents per customer multiplied by 25 cents. So then it is estimated that the restaurant will lose between $143.85 and $299.63 in the should he select to be sure that his margin of error is 5% or less. And this is a common question that pops up a lot as well. Okay, so remember, the margin of error is the part of the confidence interval that is after the plus minus norm. That's in that second VARS menu. You get 1.96, which is one of those things. So what we're going to use for our p-hat is 0.5. That is going to overestimate the error to be as large as it is for our standard deviation. So 1.96 from our z-score, our square root of 0.5 and 0.5 divided by n, because we don't know what that is in this case. Okay, we are the sample of 80, but he wants to minimize that margin of error. So he's going to be sure, he's going to estimate it to be 50% of people who get water cups use it for soft drinks. That's going to, that 0.5 times 0.5 is the largest combination you could have in the numerator there. And then we don't know n. That's what we're trying to solve for. Less than or equal to 0.05. And then we just got some good old-fashioned math. Divide by 1.96 on both sides. Square both sides. Okay. Move the n over. And then divide both sides by that 0.0006. And that gives us the n has to be greater than or equal to 384.16. So in other words, for his margin of error to be 5% or less, we need the sample size to be at least 385. We want to round up there to be absolutely sure. Okay. All right. Wrapping things up. I don't know if we're still there. I feel like I'm live here on Vimeo. Everything's working, but I don't know if people are still with me. But all right. So our non-negotiables, and remember, these are the things that we need to know our building blocks. Make sure you know what the confidence level means. It means if we were to repeat something, to proportion inference. That is the SPDC process. Be able to identify the confidence intervals and margin of error on multiple choice questions. Be able to take a problem and pick out the most algebra you probably do in AP statistics is on that one. Also understand the conditions for inference, random independent normal, be able to identify those, and also if any of those are missing. Okay, so those are the important things that you definitely need to know for confidence intervals or proportions. Okay, and hop on over on Discord. I'm sure some of you might already be there, and so we can hash things out. All right, hope you all have a great week. Sorry about the technical difficulties there.